Dear students, we will discuss the Dirac delta function in this class. এই Dirac delta function আমাদের প্রয়োজন হবে when we will discuss the charge density due to a point charge. আমি আমার প্রিভিয়াস ক্লাসে যেখানে প্রিন্সিপাল অফ সুপারপোজিশন বলেছিলাম, যেখানে আমরা ভলিউম চার্জ ডিস্ট্রিবিউশন, সারফেস চার্জ ডিস্ট্রিবিউশন, লিনিয়ার চার্জ ডিস্ট্রিবিউশন ডিল করেছি, সেখানে বলেছিলাম পয়েন্ট চার্জ ডিস্ট্রিবিউশনের জন্য উই উইল নিড ডিরাক ডেল্টা ফাংশন। আমরা এই ক্লাসে ম্যাথামেটিক্যাল ফাউন্ডেশন অফ দ্য ডিরাক ডেল্টা ফাংশন সেটা নিয়ে একটু আলোচনা করব। এর ফিচার্সগুলো আমরা দেখব, এর অ্যাপ্লিকেশন on electrostatics and the problems related to electric field, electric potentials and other things সেটা আমরা এর পরের ক্লাসগুলোতে ডেভেলপ করব। So the primary features of the Dirac delta function, I have listed them in this way. You can find them in many books. In fact, in all mathematical physics books, I am following the book of Arfken and Weber. এই Arfken and Weber এর বইয়ের সাথে I will tell you to follow the book of say Shatyaprakash or Rajput. In these books you will find a lot of exercises, in fact more detailing, but for understanding of the physical thing and how mathematics is used in the field of physics, I advise you to use the book of Arfken and Weber. So the delta x, it is equal to 0, or delta function delta x equal to 0 if the x is not equal to 0. That means all other points the function vanishes. It is the function is 0 at x not equal to 0. It shows the function is non-zero at x equal to 0. But what is the value of the function at x equal to 0 cannot be said directly. It is undefined actually, we will see it later. But the feature is defined as minus infinity to infinity, you integrate over delta x, it will give you 1, and in a more general way, fx delta x integrated from minus infinity to infinity, it will give you f0. The more general expression is written as delta x minus a multiplied by fx. So if you put a equal to 0, you obtain this one. So this will be equal to fa. I have missed the term dx here. Fx delta x minus a dx equal to function of a. This happens because at delta x minus a is 0 if x is not equal to a. That means the function has some value, delta x, the function has some value at x equal to 0. What is the value? That cannot be said directly. So you note that the limits of the integrations, in all the cases here we have given minus infinity to plus infinity, but it may not be minus infinity to plus infinity necessarily. We have to just ensure that the point on which the function is non-zero, at a point the function is non-zero, like a charge, a point charge, it has a value at that particular point, but in all other points there is no charge. Like this, at a point say x equal to a, this point has to lie within the limit we consider. If x equal to 0, then the point must lie within the limit we consider. So if our point is a, then any limit, so this is the point x equal to a, so any limit a minus p to a plus q, where p and q both are greater than 0, otherwise both of them will be in one side. Okay, a minus p and a plus q, this will be fa. Just as simple as that, because you can simply extend this limit from minus infinity to a minus p, one integration, then a minus p to a plus q, then another integration a plus q to plus infinity. That means from this region you include, this region you include, and you everywhere you find the delta function to be 0, so you just adding this thing. So this limit a minus p to a plus q is exactly same as minus infinity to plus infinity. Second thing, from equation 2, this one you see, equation 2, it is extremely important. From equation 2 we see that the delta function, it has a spike at x equal to 0. It has a spike at x equal to 0. If it is delta x minus a, then it will have a spike at x equal to a. But the spike has height tending to infinity. Its height tends to infinity. Height tends to infinity, and its width, we will see it later, and its width tends to 0. We will see the graphical picture from this equation. As simple as that, because in all other points the function has no value, and at this point it has a very high value, so that the range of the integration gives you the intervalue becomes 1. In fact, you can say that this analysis, that it has a spike of infinitely high and very narrow width, this relates to the charge density of a point charge, as I told you. In fact, it is better to compare it with a linear case, as we are dealing with one-dimensional delta function. In case of a linear charge density lambda equal to q by L, where L is the region, L is the length of the region, total length, and q is a point charge on that length. Then if L tends to 0, that means the point charge, then lambda tends to infinity. At L equal to 0 or L tends to 0 indicates actually a point, as you understand. And delta function, it is very important. It's not a proper function, so it is an improper function. Actually it is a distribution, because no such functions exist. We cannot find any such function which has a value at a particular point and no value in all other points. There is no such proper mathematical function. And as I said, the delta x minus a is not exactly defined at x equal to a. That means undefined actually. At x equal to a, it is not a function. You cannot have a value or an expression for delta x minus a at x equal to a. Then what can we do with this if we don't have an expression of a function? How can we deal with that? But all the properties of integration, under integration, expression equation number 2, equation 3 or 4, in fact you see that equation 4 is a more general form, and through which you can obtain equation 3 and equation 2. We can establish these equations as a limit of a sequence of functions. We will check it. A sequence of functions means a distribution. So delta function is sometimes known as a distribution. It is a very important point. Example of some delta sequence functions are, say, delta nx, something like it is 0 when x is less than 1 by n, 1 by 2n rather. Delta x equal to n, this n, you see it here, delta x equal to n, the graph is given here in the right side for each function, and it is 0 there. So in this region function is 0, here also it is 0, and in this region it is n. Now if you narrow this, if you are squeezing this position, and that means if you increase n, this height will increase. As n increases, this height increases in this direction. As n increases, height increases in this direction. And as n increases, 1 by 2n decreases, so this part decreases. Therefore, this graphical picture gives us a shape of delta function, an idea of the shape of the delta function, where it is infinitely high and infinitesimally thin. Another shape can be, this is a Gaussian distribution. In a similar way, if you increase this height and if you squeeze this width, if this width is getting narrowed and if this height is increased, then it will represent a delta function. Another is, this is a kind of Lorentzian distribution. The same feature here, if you go on increasing n, and this height will increase and this width will decrease, and when n goes to infinity, it will become a delta function. Another is sin nx by pi x. It can be written, you just carry out this integration e to the power ixt dt, and then you will see that it is given by this function sin nx by pi x. If you plot it, it will be like this. It has very important application in the field of optics, actually, you will see. And in all cases, note that this delta nx, the delta sequence functions, there are many functions. Any function that satisfy this relation given by equation 5 or equation 4 or equation 2, that's what, any function that satisfy all these equations can be treated as a delta function. And you note that the delta sequence function delta nx, if we take the limit n tends to infinity delta nx, no limit exists. This delta nx will not exist in the limit n tends to infinity, but under integration minus infinity to plus infinity, this is extremely important. Under integration, this limit exists. Minus infinity to plus infinity fx delta x dx, or say delta nx dx, becomes f0. It can be proved mathematically, and I tell you to carry out this at least for the first problem. Take this one as your home test. This limit exists. So such functions can be used to realize the delta function. And some properties of delta function, we just read here. The delta function, you see, they are evenly poised to the from x equal to 0 towards left, it is also 0, towards right it is also 0. So it is an even function. And x delta x equal to 0, because put x equal to 0 here, this equation becomes 0. And if x is non-zero, then delta x is 0. And delta ax, it is just a scale conversion. You can do it, just write down ax equal to z, and you will find the same thing. And then as delta function is an even function, so the sign of a will not matter, so it will be 1 by mod a delta x. From conceptual or logical derivation, we can guess the results, and for rigorous mathematical proofs, I tell you to go through any textbook, or say Rajput or Shatya Prakash, in fact any mathematical physics book. And fx delta x minus a equal to f of a delta x minus a, because this will have its value only when x equal to a, otherwise the delta x minus a will have no value. So if you put x equal to a here and you obtain this one. And these are very two important relations which are used in mathematical cases. And if the argument of a delta function is itself a function, that means delta of gx, gx is a function, that means this function, this delta function having gx as its argument, this will have a value, non-zero value, rather undefined non-zero value, when gx equal to 0. So gx, you have to solve gx equal to 0 and find out the roots, that means the values of x at which gx equal to 0. So delta function is itself, if the argument of a delta function is itself a function gx which have roots at x1, x2, it may have, gx can be a polynomial and have many roots, can have one root, can have two roots, and so on, you understand. Say xi within the given interval, at the intervals. If it is minus infinity to infinity, then okay, or if it is in a finite limit, then also we can do it in the same way. The expression can be written in this fashion, where in the denominator we use the derivative of g, and xi is the ith root of the gx equal to 0 equation. That means gx equal to 0 for x equal to xi, but g dashed is the first derivative is not 0 at x equal to xi. If the first derivative is 0, you cannot expand it, you cannot write it. And the next point is, you can write the derivative of delta x as this function. You can try to solve it, do integration by parts for the left side, and you will find it here. Take fx as the first function, then you will find the expression, and it is quite easy. Note that the dimension of delta x is L inverse, means x is length, so it will be 1 by length. But if your argument is different, say if it is argument is gx, then the dimension will be the dimension, inverse dimension of gx. So if we use theta angle, then it will be 1 by radian, that means the inverse of that one. Actually theta has no dimension, so delta theta will also have no dimension, but its unit will be written in 1 by radian. If it is say time, then if the argument is time, then the delta function will be of 1 by time, that means say a frequency. In 3 dimension, we can write as delta r vector minus a vector, as I have expanded it. And if you integrate over a volume, it will be the a vector. Just replace the 3-dimensional analogy in the 1-dimensional one. So it will be function of a when the vector r equal to a is contained within the volume, or will be 0 otherwise. And if fr equal to 1, you will get 1 here. And in cylindrical coordinates, if you take the point here, I have written, I am not going to read all the things out. The expression are given here. You can try to solve it, and you can note it. And in spherical polar coordinate, just check if you integrate this one, say this one, you are going to integrate. That means you use this relation, and then, or if you want to do it in a smaller scale, then use this one. Use this one for if you want to do it in a simple scale initially. And then at first use this expression, use the left side to show this one, and then use this expression and carry out the integration and check whether this is valid, and believe me, it will be valid, and the integration will give you the desired result. Don't take anything like fr, just check this one, that means take fr equal to 1. In spherical polar coordinates, the same thing, in the same manner the things work. We will use this expression, this one we will use it later, and we will also prove it in a rigorous way, or maybe some equivalent to it. However, we will prove it. This r is the vector and this r is the coordinate. Don't mix it, be very careful. And you check at the third one is the general thing. In spherical polar coordinates, the point r prime is general, not on z axis, not on anything. The second one is slightly reduced, that the z axis, on the positive z axis the point 1 lies. So here there are 3 delta functions, here there are 2 functions. The phi part is not here, but the phi part comes through 1 by 2 pi in the denominator. And at the origin the theta part is also not here, and it becomes mixing with phi and theta, it becomes 1 by 4 pi. So everything is actually there. There is no problem in the dimension, the things are actually integrated out. Check it in your own hand, and note that in 3 dimension of delta r is L to the power minus 3, that means 1 by L cube. And in dimension, it is also to note that in 3 dimension delta r is also written as del cube r. In many books you will see it. So we will end here and use it in our next class.